Third question for chapter 1 and 2 exercise, that's based on this particular data. It's given in the form of table, country, carbon dioxide level, and you have been asked to calculate the 5 number summary and explain why the summary suggests the distribution is right scale. The first thing in plotting any kind of data is to have the data in sorted order. Just see if the data is sorted according to some ascending or descending order, and you can see that it is right away not sorted data. So you have to first sort the data and then go for whatever they have asked. For the 5 number summary, remember that the 5 number summary is nothing but minimum value, then Q1, that is the first quartile, median value, Q3, and the maximum value, right? So these 5 numbers we have to find it out. So we can certainly see that the median Q1, Q3 are also based on the principle that these are like middle values among the data sets. So that is another reason why we have to sort this data. So I have just sorted this number here. So just based on this carbon dioxide levels, for the interest of time, I have just sorted it out. And once I have sorted them, I have also ranked them up according to their position. And these are total 48 data points. So you can also write the name of country for the data points, but I just avoided that and listed only some of the things which might be interesting for our question. So once you have sorted the data set and listed the position of each data point, you also know that these are n of 48 values, right? So now let's go ahead and look at the median value. So how do we get the median? So the formula for median is n plus 1 divided by 2, where n is the total number of data points. So when I have ranked them, it comes to be 48. So n here is 48. So 48 plus 1 divided by 2, that is 49 divided by 2, that is nothing but 24.5. And that is nothing but the position. So that median has the position in sorted data point between 24 and 25. That is what we mean by this. So now let's look at the value of median based on this position. So let's locate the position between 24 and 25. And remember, this is not given. You just rank it to have this position. So it should be in between these 2 points. So basically you take the average of these two, 3.3 plus 3.3 divided by 2, and that is nothing but going to be 3.3. So that is what your median is. So now you know that the median lies here, 24.5. So for the first quartile, Q1, you know it is based on the same principle. It's going to be the median of the first half of data set before the median. So you can see if the median lies at 24.5, then first 24 data points are going to be in your first half, right? So n here becomes n1 plus 1 divided by 2, and since this is 24.5, the n1 becomes 24. So it should be something around 12.5, and that's also the location of position, right? So just locate between 12th and 13th position, which is nothing but between this. So take average of these two numbers and that should be 0.95, right? So write the values here. Now let's look at the Q3. That's the third quartile, which can be n3 plus 1 divided by 2. And you just have to see what n you're taking. You can conceptually take all the numbers below this median, which is also going to be 24 other next 24 data points, and then you can take half of that, that is 12.5. But then you have to start ranking these data points as 1, 2, 3, 4, 5, 6. So right away you know that your 12.5 Q3 should be somewhere in here, right? So take average of this, 7 plus 7.8 divided by 2. And that should come up to 7.4 Q3. So notice that although we have taken the n as the same lower half number and got the same Q3 position, that Q3 position is from median. Now there are several other methods as well. Check out the other parts of video or read the textbook. But you can go for whichever you want as long as you justify. Notice this is the position from median, and that is why we have started ranking or numbering the positions from median again to the higher value or higher position. And that's how we got the Q3 as 7.4. So these are positions and these are actually the values based on your data. And remaining part of the 5 number summary is the minimum and maximum value. And these are pretty easy as long as you have sorted it in some order, preferably ascending. So you can see that this is the least value we have in data set, so that becomes your minimum, 0.1. And then the maximum value would be 19.6 in this case. Notice that we are still not dealing with outliers here, so as of now we are saying that it's 19.6 is the maximum value, but we are going to deal with the outliers in the next steps. So at that time we would know that what is the actual maximum value versus outlier. So we have completed this step. Now explain why the summary suggests the distribution is right skew. So basically if you graph this, you can certainly see that difference, but you can also justify your answer based on the difference in these distances. So let me show you how the graph would look like. So if you want to, so let me just borrow this space as some rough space. And let's say if you want to plot this box plot, because box plot is the one we use to represent skewed data, right? And you're going to have something like that, right? So median is the center. You have the value of median as 3.3. So it is 3.3. This is Q1, which we have it as 0.95. Q3 as 7.4. And now we have to plot minimum and maximum value here. So let's look at the minimum value first, zero point 0.1. And if you can see the scale, zero point 0.1 should be very close to this, right? So you can see that this should be minimum value. So let me draw it closer. So minimum should be here, zero point 0.1, right? It is very close to this compared to the other distances. And if you look at maximum is 19.6, so it's way away from both the median and the quartile. So you're probably going to draw something like this, right? So now looking at the graph itself, you can say that this is right skewed. But how are you going to justify this? So that's actually based on these distances. So you have to calculate this distance from the maximum till Q3, then from Q3 to median, median to Q1, and Q1 to minimum. So let's look at the first distance, that is distance 1, that is from maximum to Q3. So just subtract maximum number, which is in this case 19.6, minus 7.4, that should give you somewhere around 12.2. The second distance D2 is the distance from Q3 till median, 7.4 minus 3.3, that should be somewhere around 4.1. Similarly, D3 is from median Q1, or Q1 is 9.5. Sorry. All right. And the last distance, that is from Q1 till minimum point. So Q1 is 0.95 minus 0.1, that should be 0.85. Now just compare these distances and think whether you can justify based on that. So you can see that this first two distances, that is 0.85, 2.35, are shorter if you compare them with the other distances on the higher end, and especially this one is like too far, right? So based on this distances, you can say that the data is more stretched on the upper end or towards this higher value according to the ranks, and that's why it is skewed on that side, which is nothing but the right side in ascending order. That's why you can justify that this data is skewed to the right. Okay. So B part is which countries are suspected to be outliers. So you have to find the outliers. So at that time you need to know what data point represent which countries. So I have just written down the names of some countries, but you can list it all if you want to practice. But in order to qualify it as an outlier, we know that we have to use this criteria, cutoff point or rule of 1.5 times interquartile range. So let's first go ahead and calculate how much is the 1.5 times interquartile range, right? And that is cutoff criteria for outlier. Right? So interquartile range is nothing but the range between the two quartiles, that is Q3 minus Q1, right? And Q3 minus Q1 we know is going to be 7.4 minus 0.95. 7.4 minus 0.95, and that should be 6.45. Once you got this interquartile range, just substitute that value in this formula and get the cutoff. So 1.5 times interquartile range is nothing but 6.45, and that should give you value somewhere about 9.675. Got this value. We know that the cutoff for outlier could be on either end. So any value lower than the lower boundary or higher than the higher boundary, we call it as an outlier. So we have to see it on either end. That is why we are doing this. We already solved this 1.5 times interquartile range here, and we got is 9.6. So we are going to have 9.675 subtracted from Q1, that is nothing but 0.95, and that should give us minus 8.725. That would be cut off for to be qualified as an outlier on the lower end. On the higher end, remember, it is always going to be positive because we want it to be higher than or further away from the higher boundary. So we are going to add that same number in 1.5 times interquartile range to the Q3, which is nothing but 7.4 here. And that should give us something about 17.075. So now we can say, based on this particular information or calculation, that if we have in our data set any value which is less than this particular value, that is negative 8.75, then it is going to be an outlier. But do we really have any value which is less than even 0.1? No. So that means we don't have any outlier on the lower boundary, right? Now let's look at the higher boundary. Do we have any value which is greater than this particular number, 17.075, on the higher end, right? Because we want it to be further away from the higher end. 17.075. So we can certainly see that these two numbers, 18.4 and 19.5, qualified as outlier because those are more than the cutoff, right? So mathematically those are actually outliers. But you can also consider Canada's values, which is all close to the mathematical value 7.075, right? It's actually very close to 17, but that's the subjective decision you might want to make, right? But mathematically this is correct. So either of these answers, both three of these countries are the outlier, or both Australia and US data point is considered as an outlier, right? So we have solved this part. The second subtype of this 2b or 3b, make a dot plot or a stem plot of the data. So dot plot is pretty simple. You just have to create a scale based on this range till 19.6. Create the dot according to scale. If you have the same values, just stack them up one on top of each other. And also watch the other video recorded for dot plot. So I'm not going to repeat that one. Stem plot is also, we've covered it, but the point here is because we have already always used leaf unit as one, um, meaning that if you have value of 9, then you are going to consider 9 as leaf, 9 as leaf, and 0 as your stem, right? So this is leaf and this is stem. That is when leaf unit is 1. But you can also decide those leaf unit and change those leaf unit according to your data, um, and you can plot it as leaf unit with point 1. So you can mention that the graph you are making, for that the leaf unit is 1 over 10 or point 0.1, and sort the data with the standard procedure what we have covered. Or the other way I would say you should do is, because we are not going to go over in too much details with the leaf unit as a part of this course, so I'm going to tell you the same way that we covered with leaf unit 1. So if nothing is mentioned, leaf unit is not mentioned, it should be considered standard 1, right? So for that, how are you going to represent these point 0.1, point 0.1, point 0.1, point 0.2, point 0.3, point 0.9? How are you going to represent these data points in that stem plot? So basically we should be doing here rounding if we are using the leaf unit as 1. So basically all the data points till you hit the 1 number, so till this 12th point, I cannot highlight that because I annotated that, but just understand that the first 12 points are going to be till point 9 are going to be all considered as somewhere close to 0, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And you can see that there are 3, 6, 9, 10, 11, 12, 12 zeros, right? And notice that we are rounding it to the closest, not closest figure, but we are just rounding it according to the that value, so that we will have clear distinction for those who have ones and twos, threes, and so on, right? So for the ones, we can see that all the values greater than 1, so that's the solid cutoff we have decided here. So 1, 2, 3, 4, 5, 6, 7. So 7 ones, 1, 2, 3, 4, 5, 6, and 7. That's why we have listed all this as 7, and notice that it has got stem as 0. So like that you can do that and create a stem plot here. Right? But make sure at least you know how to create the dot plot, and that should be fine. Once you plot it by using either of these, that's why I have listed it, or after completion just look at the graph and see if you agree with the rule suggestions about which countries are or are not outliers, right? So basically if you look at this, if that is the only answer question you want to answer, you can just simply go ahead and do something like this rather than drowning into those leaf units. And you can certainly notice that this is the 18th value, so that would be rounded off value for Australia, 18.4, and The second data point would be this 19 value, that would be rounded off version of 19.6, which is for US. And you can see that these two data points, you can also see that it is graphically away from the majority of this data set. It will be more clearer if you do the dot plots visually. So that is the last question.